To determine the load on the photocell, you need to consider the following factors: lamp wattage, ballast factor, and photocell power consumption. In your case, you have three 150-watt lamps, which gives a total lamp wattage of 450 watts. Ballasts used with HID lamps, including high-pressure sodium lamps, consume additional power. The ballast factor is a percentage that represents the additional power consumed by the ballast. For most HID ballasts, the ballast factor is in the range of 1.2 to 1.3. Photocells also consume a small amount of power. The power consumption of a photocell is typically in the range of 1 to 5 watts. Based on these factors, the load on the photocell can be calculated as follows: the load on the photocell equals lamp wattage times ballast factor plus photocell power consumption. In your case, assuming a ballast factor of 1.25 and a photocell power consumption of 2 watts, the load on the photocell would be load on photocell equals 450 watts times 1.25 plus 2 watts equals 565 watts. Therefore, you would need a photocell that is rated for at least 565 watts. It is important to note that the load on the photocell should not exceed its rated capacity, as this could damage the photocell. Let's dive a little deeper into each of these factors and why they are important when sizing a photocell for high-pressure sodium, or HPS, lighting. Understanding these principles will help you select the right components for a safe and efficient lighting system. First, let's talk about lamp wattage. This is the most straightforward part of the calculation. You simply add up the wattage of all the lamps that the photocell will be controlling. In your scenario, with three 150-watt HPS lamps, the total lamp wattage is 450 watts. This is the baseline for determining the overall load. Next is the ballast factor, a crucial element that often gets overlooked. Ballasts are essential components for operating HID lamps like HPS. They regulate the voltage and current supplied to the lamp, ensuring it operates correctly and safely. However, ballasts themselves consume power in addition to the power used by the lamp. The ballast factor represents this additional power consumption as a multiplier. For example, a ballast factor of 1.2 means that the ballast consumes an additional 20% of the lamp's wattage. The ballast factor typically ranges from 1.2 to 1.3 for most HID ballast. You can usually find the ballast factor printed on the ballast itself or in the manufacturer's specifications. To accurately calculate the load, you need to multiply the total lamp wattage by the ballast factor. This gives you the total power consumption of the lamps and their ballasts. Thirdly, consider the photocell power consumption. While relatively small, the photocell itself consumes a bit of power to operate. This consumption is usually in the range of 1 to 5 watts. It's important to include this in the calculation to get a complete picture of the load on the photocell. Now let's put it all together. The formula for calculating the total load on the photocell is as follows: total load equals lamp wattage times ballast factor plus photocell power consumption. Using the example you provided, we have three 150-watt lamps, so the lamp wattage is 450 watts. Assuming a ballast factor of 1.25 and a photocell power consumption of 2 watts, the calculation is as follows: total load equals 450 watts times 1.25 plus 2 watts, which equals 565 watts. This means you need a photocell that is rated for at least 565 watts to safely handle the load. It's always a good idea to choose a photocell with a slightly higher rating than the calculated load to provide a margin of safety. Overloading a photocell can lead to overheating, premature failure, and potentially even a fire hazard. Therefore, it is extremely important to select a photocell with an adequate rating. In summary, accurately calculating the load on a photocell involves considering lamp wattage, ballast factor, and photocell power consumption. By using the correct formula and taking these factors into account, you can ensure that your photocell is properly sized for your HPS lighting system, promoting safety, reliability, and longevity. Now let's delve into some additional considerations and best practices when working with HPS lighting and photocells. These tips can help you optimize your lighting system and avoid potential problems. Firstly, consider the ambient temperature. The performance and lifespan of both ballasts and photocells can be affected by ambient temperature. High temperatures can cause ballasts to overheat and fail prematurely. Similarly, photocells may experience reduced sensitivity or accuracy in extreme temperatures. Ensure that your lighting fixtures and photocells are installed in locations with adequate ventilation to prevent overheating. Secondly, think about voltage fluctuations. Voltage fluctuations can also impact the performance of HPS lighting systems. Low voltage can cause lamps to flicker or fail to start, while high voltage can shorten their lifespan. A stable voltage supply is essential for reliable operation. Consider using a voltage regulator or surge protector to protect your lighting system from voltage fluctuations. Thirdly, always use high-quality components. Investing in high-quality ballasts, lamps, and photocells can save you money in the long run. High-quality components are typically more durable, efficient, and reliable than cheaper alternatives. They can also provide better light output and color rendering. When selecting components, look for reputable brands with a proven track record of performance. Fourthly, perform regular maintenance. Regular maintenance is essential for keeping your HPS lighting system in top condition. This includes cleaning the lamps and reflectors, checking the wiring connections, and inspecting the ballasts and photocells for signs of damage or wear. Replace any damaged or worn components promptly to prevent further problems. Fifthly, consider energy efficiency. HPS lighting is known for its energy efficiency compared to traditional lighting technologies like incandescent lamps. However, there are still ways to improve the energy efficiency of your HPS lighting system. Firstly, use electronic ballasts. Electronic ballasts are more efficient than magnetic ballasts, reducing energy consumption and heat generation. Secondly, use light sensors and timers. Light sensors and timers can automatically turn off the lights when they are not needed, saving energy. Thirdly, use reflectors. Reflectors can help to direct the light where it is needed, reducing light pollution and improving energy efficiency. 6. And lastly, follow local electrical codes. Always follow local electrical codes when installing and maintaining HPS lighting systems. Electrical codes are designed to protect people and property from electrical hazards. Make sure that all wiring is properly installed and grounded and that all components are rated for the intended use. In addition to these tips, it is also important to be aware of the potential hazards associated with HPS lighting systems. HPS lamps contain high-pressure sodium vapor, which can be harmful if inhaled. If a lamp breaks, avoid contact with the broken glass and sodium vapor. Wear gloves and eye protection when handling broken lamps. Also, HPS lamps produce a significant amount of heat. Avoid touching the lamps when they are hot to prevent burns. Keep flammable materials away from the lamps to prevent fires. By following these safety precautions, you can minimize the risks associated with HPS lighting systems. Moreover, let's discuss some common troubleshooting tips for HPS lighting systems. If you encounter problems with your HPS lights, here are some steps you can take to diagnose and resolve the issue. Firstly, if the lamp does not light, check the power supply. Make sure that the circuit breaker is turned on and that the voltage is correct. Secondly, check the lamp. If the lamp is burned out, replace it with a new one. Thirdly, check the ballast. If the ballast is not working, replace it with a new one. Fourthly, check the wiring. Make sure that all wiring connections are tight and that there are no loose wires. Fifthly, if the lamp flickers, check the voltage. Low voltage can cause lamps to flicker. Consider using a voltage regulator to stabilize the voltage. Sixthly, check the ballast. A failing ballast can also cause lamps to flicker. Replace the ballast if necessary. Seventh, if the lamp is dim, check the lamp. A dim lamp may be nearing the end of its lifespan. Replace the lamp with a new one. Eighthly, check the ballast. A failing ballast can also cause lamps to dim. Replace the ballast if necessary. Ninth, if the lamp changes color, check the lamp. A lamp that changes color may be nearing the end of its lifespan. Replace the lamp with a new one. Lastly, check the ballast. A failing ballast can also cause lamps to change color. Replace the ballast if necessary. By following these troubleshooting tips, you can quickly diagnose and resolve common problems with HPS lighting systems. Now let's explore some advanced topics related to photocells and lighting control. Understanding these concepts can help you design and implement more sophisticated and energy-efficient lighting systems. Firstly, discuss dimming photocells. Dimming photocells can automatically adjust the light output of HPS lamps based on the amount of ambient light. This can save energy and improve visual comfort. Dimming photocells typically use a sensor to measure the ambient light level and then adjust the voltage supplied to the ballast accordingly. Secondly, discuss networked lighting control systems. Networked lighting control systems allow you to control and monitor your lighting system remotely. This can provide valuable insights into energy consumption and system performance. Networked lighting control systems typically use a central controller to communicate with individual lighting fixtures and sensors. Thirdly, discuss daylight harvesting. Daylight harvesting is the practice of using natural daylight to supplement or replace artificial lighting. This can save energy and improve visual comfort. Daylight harvesting systems typically use sensors to measure the amount of daylight available and then adjust the artificial lighting accordingly. Fourthly, discuss occupancy sensors. Occupancy sensors can automatically turn off the lights when a space is unoccupied. This can save energy and reduce light pollution. Occupancy sensors typically use infrared or ultrasonic technology to detect movement in a space. Fifthly, talk about time clocks and schedules. Time clocks and schedules can be used to turn on and off lights at predetermined times. This can be useful for security lighting or for reducing energy consumption during off-peak hours. Time clocks and schedules can be programmed manually or using a computer. 6. Discuss integrating with building management systems or BMS. Integrating your lighting system with a building management system can provide a comprehensive view of your building's energy consumption and system performance. BMS systems can typically monitor and control various building systems, including lighting, HVAC, and security. 7th, consider the Internet of Things, or IoT. The Internet of Things is revolutionizing the way we control and manage lighting systems. IoT devices can be connected to the Internet and controlled remotely. This allows for greater flexibility and control over your lighting system. 8. Discuss smart lighting controls. Smart lighting controls are becoming increasingly popular. These controls use advanced algorithms to optimize lighting performance and energy efficiency. Smart lighting controls can learn your lighting preferences and adjust the lighting accordingly. 9th, delve into energy monitoring. Monitoring your energy consumption is essential for identifying opportunities to save energy. Energy monitoring systems can track your energy usage in real time and provide detailed reports. Lastly, discuss data analysis. Analyzing your lighting data can help you identify trends and patterns that can be used to optimize your lighting system. Data analysis can reveal valuable insights into energy consumption, system performance, and occupancy patterns.